Understanding call admission control. Call admission control is the little brother of quality of service, right? Quality of service is the famous one. He's on the screens, all the lights and the actions because, rightly so, he protects your video and your voice from your data traffic. You got this guy surfing YouTube in the middle of the day across your T1 line that also hosts video and voice traffic. Well, quality of service steps onto the scene is like, bam! I don't think so, YouTube. This phone call is going to go through. You need to go sit down, and the video gets all chopped up and all that kind of stuff. And that's awesome, and that's great because quality of service can quickly identify, hey, that guy surfing the YouTube is not voice and not video traffic, at least the kind of video that I've chosen to prioritize. But what happens when you've got this guy and this guy and this guy all placing calls across the T1 line? Now you've got all this quality traffic or high priority traffic that needs to use the T1 line, and quality of service is going, there's no evil villain to smack down, right? That's where call admission control comes in. Call admission control comes in 4 flavors depending on what kind of setup you're using. If you got a whole bunch of H323 devices, then the H323 gatekeeper is the way to go. Now, you'll typically see in a network diagram, they'll have kind of this hanging router that they're like, yeah, that's the H323 gatekeeper. And for years, when I would see that, I'm like, where is that thing? Is it just like floating in the cloud somewhere? Well, in actuality, it's probably one of the voice gateways that has a little more horsepower. You pay a little bit more for the iOS version, and you get an H323 gatekeeper. And essentially, all the H323 devices, let's just say it's the routers, check in to the H323 gatekeeper, and you, the admin, go on that H323 gatekeeper and set up the zones of bandwidth. You say, okay, from here to here we've got, X amount of bandwidth. From here to here we have Y amount of bandwidth. These sides, Z amount of bandwidth. So you set up all of these things in the command line interface. It's not pretty. I'm not saying there's a nice little GUI where you drag and drop. You really are putting it in the command line, but it works well. This also gives you a central point of dialing as well, so you don't have to set up full dial plans on each one of these devices, because they can just say, hey, H323 gatekeeper, tell me where to go to reach extension 55, which is this guy, right? And it can point them in the right direction. So the gatekeeper works amazingly well when you got H323 devices. How about VCS? Well, the video communication server specifically geared towards teleconferencing has this concept known as a subzone. Go around setting up subzone Phoenix, subzone Australia, subzone Detroit, and you get to say what kind of limitations those have in terms of bandwidth. You can say, hey, there's no bandwidth available in Detroit, which immediately exempts it from any kind of video calling. This guy's kind of out of luck at that point. You can say, okay, we've got some limits, which says I've got this guy at 500 kilobits per second. This one's at 1,000 kilobits per second. And remember, this is specific to video communication. I mean, maybe this guy is actually a 3 megabit per second link, right? But quality of service is set up to where you only have a priority queue using that low latency queuing we talked about to prioritize 1 megabit per second of bandwidth. Well, that would be the amount that you would choose to say is available using these subzones. Or, you could say, well, I know this guy's, giant Metro Ethernet, gigabit per second connection, so I'm not going to put any limits on Phoenix whatsoever, and all video telephony calls can go in and back and forth. So, same idea with CUCM. It's just instead of calling it subzones, they call it locations. And without repeating myself all over again, it's exactly the same concept. You create all of these locations and assign the specific bandwidth. Now, the key to catch with these things is they work really well for what's called hub and spoke topology. So when I've got, let's say, this guy right here, which is the hub, going to this spoke and this spoke, these work really well because you kind of have that central point of control. But when you start having, spoke calling spoke and spoke, going out over here, then the subzone location idea kind of breaks down, and that's where we step in with RSVP. RSVP doesn't stand for anything technical. If you look it up on Wikipedia, it's actually a French phrase, répondez s'il vous plaît. 4 years of French in high school. That's pretty much all I got out of it. So RSVP is a system that allows you to go into each one of these routers. And this diagram doesn't work as well for it. So let's just say we've got all these routers going in a little chain. Over here you've got, let's just say, our Phoenix office with a little video telephony thing going on. And you've got all of these routers all the way going over to Australia. Right. And so over there, we've got our own little video telephony system going on. So what can happen is before that call is allowed, you can configure these things to participate in RSVP. Now, the cool thing about RSVP is it's super flexible. Can handle just about any topology you can throw at it. The not so cool thing about RSVP is it's all the way through. Like if you got one device in the middle, like that guy right there, he doesn't support RSVP, the whole thing kind of just, well, I don't want to say collapse and burn and, death and destruction. I'm just saying, he's the weak link in the chain. So if he's got a WAN link and some other stuff going on where traffic's coming in, then you're not going to get that true end-to-end quality of service. Oh, but here's how it works. So when you go into the video telephony device, he sends an RSVP packet, this little gem, before the call ever is allowed. So you go in there and you dial extension 111, which happens to be this guy in Australia. So the first packet it sends is an RSVP packet saying, "Hey, I'm trying to make a call. And I'm going to need, let's just say, 1 megabit per second of bandwidth for that call. Is that cool?" And this router looks at its bandwidth available and all the RSVP reservations you've got set up. It's like, "Oh yeah, that's cool. Send it through." Okay. Yeah, cool. Good. Hopping all the way down. Now at the very end, this guy's like, whoa. Sorry. No megabit per second of there. Call is not allowed. Now you can set this thing up to where it can have a different path. Maybe you got an alternate network route, but essentially RSVP or RSPV allows you to reserve that megabit per second all the way through for the length of that call, and essentially that becomes your priority queue. Once the call's disconnected, shoop, all that bandwidth is added back in. So while it may be the little brother to quality of service, you can see that call admission control, mission critical. You gotta have something that protects your voice and your video from overwhelming itself across your WAN links and bandwidth constrained connections. I hope this has been informative for you, and I'd like to thank you for viewing.